last topic for Module 1, Lesson 2 is all about fluids. Just the basic principles and concepts applied in fluids, because fluids, the same with statics and dynamics, it also has two parts, because when we're going to study fluids, we are dealing with the fluid mechanics field. So ang fluid mechanics po na siya duha. So we have fluid statics and fluid dynamics. So in our discussion for today, we are going to touch important concepts lang and principles na inyo magamit later on. So I choose these 4 subtopics. So the first one is basic concepts about density, specific gravity, specific weight, and pressure. Pressure that is applied on fluids, because of course we have pressure applied on solids, and we call that one as stress. Okay, so the second one is viscosity, the third is surface tension, and the last one is the Bernoulli Principle. So Bernoulli Principle is one of the topics included in fluid dynamics, because it studies fluids in motion. Okay, so without further ado, let's start with the density, specific gravity, specific weight, and pressure. So let's start with the density. Okay, it is defined as the compactness of a certain object. Okay, and it is the ratio of your mass. Okay, that is the ratio of your mass over the volume. So meaning, if you are massive and then you just consume a tiny amount of space, let's say this one, so can siya dako kanya siya mass, and then as you notice, its volume is very small, so therefore it is dense. Compared to this, dako tuod siya, but aya mass is very tiny compared with this. So let's say M1, let's say M is greater than M1. Okay, so kani siya mass less dense ning kaning second object compared with the first object, assuming that the mass of the first object is greater than the mass of the second object. So this is the density, just the ratio of your mass and the volume. Okay, so we're going to talk also the density of most fluids. So are you familiar with the value of the density of the water? Familiar ba mo, class? Density of the water. One, unsa may unit? One, unsa may unit? Okay, for the density, so balik ta sa dimensional analysis. So mass is in kilogram, volume is in cubic meter. So therefore, this is our standard dimension for density, or you can have grams per cubic centimeter. Now for water, that is standard 1000 kilogram per cubic meter. That is measured when water has a temperature of samantay standard sa physicist, that is 4 degrees Celsius at standard temperature and pressure, atmospheric pressure. Okay, at STP. So man siya inyong yung mga constant kay throughout sa inyong kanang college, especially in your higher subjects, kani balik-balik yun because usa sa inyong mga major subjects kay kanang fluid mechanics. So kani masugatan ninyo density sa water, ayo calamity, and also the density of air. Any idea on sa value sa density of air? Na idea? So ang density sa air is equal to 1.18 kilogram per cubic meter at 4 degrees C. Standard temperature and pressure approximately. Other books, nasa value ang 1.2. So, gi-round off na lang 1.2 or 1.18. So, ang uban 1.18, ang uban kay 1.2. So, 1.2 kilogram per cubic meter. So, nganong water and air man may kanang kwan commonly used sa mga problems because, di ba, fluids is kanang kuan comprised of liquids and gases. So again, ang fluids not only kanang kuan limited to kuan liquids. Ang fluids kay kuan na siya, apply po na siya sa gases. So gases are part of fluids. Okay, so again, the massive you are, then you have also a higher value of your density. So again, kung magkanam og dako ang atong volume, so magkanam pug ka gamay ang atong density. That is why for gases, they have small value of density compared to solids and kanang liquids because they occupy a lot of space than the others. Okay, so this is density. The next one, we're going to talk about specific gravity. So specific gravity. Specific gravity. Okay, specific gravity, abbreviated as SG. Okay, SG. Class, in based on your understanding, unsa may specific gravity, SG. Unsa man na siya, class? Nakasugat mo ani ng mga kuan topics in your senior high school? Unsa man siya? Specific gravity related po niya sa density of a material. Now, kung wala idea, so ang specific gravity is just the criteria of the density of a certain object compared to the standard density, or ang atong gitawag nga reference value. So ang specific gravity nag-compare ni siya sa density sa lain nga object compared to the standard or ang reference value. And what is our reference value? So for specific gravity, ang atong reference value is the density of the water, which is equal to 1,000 kilogram. So okay, nag-respond. So that is 1,000, then this is 1,000 kilogram per cubic meter. So mo ni siya ang ato ang standard of comparison with the other objects. So ang specific gravity is just the ratio of the density of any object, whether it is solid, other liquids, or other gases. Density of the object with respect to the density of the water. So if we have a specific gravity, equal to 1, what does it mean, class? So may pasabot ani. Okay, that is water. How about if the specific gravity is less than 1? Sa man iyahang gimin ana. If the ratio of the density of the object and the density of the water is less than 1, unsay pasabot ana niya? Unsa may indication ana? May idea? Oh, anything else sa the water, and then unsa man na siya, kanang mo sink ba siya or mulutaw ba siya sa tubig? Okay, so it floats in water. So mulutaw siya tungod kay less dense siya sa tubig. So example ana is ang density sa ice. So di ba ang ice kung inyo ma-notice mo float siya sa tubig, or even styrofoam. So ang styrofoam less dense siya sa water, so therefore mo float siya. Mo nang ang value sa ilang mga specific gravity is less than 1. How about if our specific gravity greater than 1? So automatic na it sinks. It sinks in the water. So example ani kay kanang mercury, Hg. So ang mercury di ay mercury. So ang density sa mercury, Hg, dapat inyo po ni ikuan, inyo po ni take notice. 13 ay specific gravity na lang. The Sg, so the specific gravity of mercury manggod is equal to 13.6. So kita, that is 13.6 times the specific 13.6 times the density of the water. So manay both pasabot sa specific gravity. Now, let's say you are only kanang kuan given with the specific gravity of a certain kanang object, and then your goal is to find the density of the object. So unsa may inyong buhaton ini? So inyong buhaton is okay ato say, so what, let's say the specific gravity of an oil is equal to let's say 0.8. Okay, 0.8. So again this value, true value gini siya because 0.8 is less than 1. So therefore, kung makabantay mo, diba, ang oil kay mo float sa water because oil is less dense than the water. Now, if we're going to find the density of that oil, so, kung sa ito buhaton, so you just use the formula of the specific gravity, because we all know that the specific gravity of a certain object, in this example that is oil, is just equal to the density of the oil divided by the density of the water. Okay, so wait lang, may nag-join. Okay, over the density of the water. So you just simply take the kanang kuan, or you just cross multiply both sides of the equation. So that is density of the oil is just equal to the density of the water times the specific gravity of the oil, which is given. So you just multiply, that is 1000 times 0.8. So ang density sa oil is just 800 kg per cubic meter. So again, if in the problem dili given ang density sa object but given ang specific gravity, so kaibaw na ta because specific gravity is associated with the density of the object and the reference value of our density of the water, or the standard value of our density, which is the density of the water equal to 1000 kg per cubic meter. So walay pangutana ni. Walay pangutana. So i-remember gini siya, ang mercury common gyud kani siya sa mga problems. So again, naa mo yung mga constant nga dapat ninyo tigaman, katong density sa water, density sa air, kaning specific gravity sa mercury equal to 13.6. Kay importante gyud na because we cannot assure that some problems will provide you these constants. Di ta maka-assure. Other books will provide but some books dili mag-provide. So be sure nga ready ka. Okay, so we're done with specific gravity. So let's proceed to specific weight. So importante po ning gitawag nilang specific weight. Okay, specific weight is abbreviated as this. So mo siya kuan kanang gamma. Okay, gamma siya, gamma. And then specific weight class is just the siya is just the density of your object. Okay, wait lang na nag-join. Okay, ang specific weight class is just the product of the density of your object. Let's say you're going to find the density, the specific weight of the object. So that is the density of the object multiplied by the acceleration due to gravity of the kanang celestial body kung asa siya na belong. So here, now that's Earth. So G, this is equal to 9.81. So dimensional analysis, sa may expected nga dimension for our specific weight, that is the density is in kilogram per cubic meter standard, then multiplied by the gravity, that is a meter per second squared. So we all know that if we're going to combine this kilogram meter per second square, we can achieve what? Unsa man class? Unsa may ma-achieve nato nga dimension, other dimension that is equal to kilogram meter per second squared. Unsa man class? Unsa may other equivalent sa kilogram meter per second squared? Okay, Newton. So that is Newton. So therefore, we have Newton per cubic meter. So therefore, ang ato ding specific weight is just the ratio of the force exerted by your object per unit volume. So again, mo na ang formula sa ato ang specific weight. So let's say for water class, sige daw, let's say for water, we're going to find the specific weight of water. Tungod kay mao man na siya ang common nga kanang fluid nga ato makitaan for every problem namgi tubig. So for water, that is gamma of H2O or W is equal to the density of the water multiplied by the Earth's acceleration due to gravity. So we all know that the value of the density of the water, that is 1000 kilogram per cubic meter, then multiplied by the gravity, which is equivalent to 9.81 meter per second squared. Then simplifying, that is 9,810, that is Newton per cubic meter, or you can just convert this Newton into kilonewton. So that is 9.81 kilonewton per cubic meter. Now, it's your task na lang class to convert the specific weight of the water in English system, and that is 62.4 pound per cubic feet. So mo na siya ang kinahanglan ninyo nga mga constants nga inyong hinumduman kay gamit yung kay na siya when we are answering some kanang problems in fluid dynamics. So again, inyo na lang ning task kaning i-prove ninyo nga ang equivalent sa specific weight for water in English system is 62.4 pound per cubic feet. So actually conversion na siya class. Okay, how about for How about for air? So ato daw pangitaan ang specific weight sa air. So for air, specific weight. Okay, so pila ra gud to? Nakainamdom pa mo? Unsa to ay density sa air, because specific weight is density sa air multiplied by acceleration due to gravity for air. So do you remember ang density sa air from the previous slide? What is the value again? (1.18). Okay, di ba? So 1.18 kilogram per cubic meter multiplied by the acceleration due to gravity, that is 9.81 meter per second squared. So therefore, ang ato ding specific weight nato sa air is 1.18 multiplied by 9.81. The answer is 11.58, approximately 11.58. So ato erase balik. That is 11.58 Newton per cubic meter. Okay, so kung dako kay ka og specific weight class, meaning dako kay kag force nga i-exert at a small volume. Even if gamay ra kag volume, bisag gamay ra kag volume, if you have a greater value of your specific weight, so therefore dako kay kag force nga ma-exert. Okay, mo na siya ang kanang meaning sa specific weight of a certain fluid or substance. Okay, so walay pangutana ni regarding ani nga ani nga principle. Okay, so walay pangutana. Then let's proceed to the final concept for this first nga topic. So let's discuss about pressure. Pressure specifically applied to fluids, of course. So we have air pressure and water pressure. So again, elementary definition of our pressure, that is abbreviated as P, equals sama to class. Pressure is the ratio of force over area. Okay, what is the direction of the force with respect to our area? Someone, let's say you have an area here, or you have a rectangular plane. So diba yung mata, that is the ratio of the force over area. We all know that the force is a vector quantity. So unsa may direction sa atong applied force with respect to the area? Okay, that is perpendicular to the surface. So please, ay gina siya kalimti. So again, the pressure acts perpendicular to the area, because the force also acts perpendicular to the area. So again, both the pressure and the force are vector quantities. Okay, but when we are kanang class studying the pressure of a fluid, so basically we can still use this elementary definition of the pressure, that is the ratio of the force over area. But kung ato ning ma-derive, actually somewhat mulahi ang iya formula, but still nagikan gyapon ni siya sa ato ang elementary definition of pressure. So for fluids, kumana siya, for fluids class, let's say we have here a tank. Okay, natay tank ani, and then atay water. Then the water, of course, has a height, diba? Ang water na height. And then ang tank pod, of course, napod siya cross sectional area, AC. So this is the cross sectional area na siya height. Okay, atong goal ani is we're going to find the pressure at the bottom. So atay butang that is the pressure at the bottom. Okay, pressure at the bottom. So in order to find the pressure, this is water this is water. Okay, in order to find the pressure at the bottom of this tank, atong buhaton is, of course, we're going to use the elementary definition of pressure. So that is P at the bottom is just equal to, sa may force nga hingaka na, of course, this entire water here, kaning entire nga tubig, of course, hing push, diba? Hing exert na siya force downward, right? Mag-agree ba mo? Ang ato ang nga tong water, may push yun na siya force ari. So if atom guna if we are to draw the FBD, in this case FBD, so mo na siya nahitabo, that is the force that is exerted by the water, or that is just the weight of the water is equal to the pressure, or the kanang force due to the pressure exerted by the tank. Of course, dapat for every action nagigay opposite reaction. So therefore ang kanang force due to the pressure at the bottom is just the same as the weight of the water, because of the kanang analysis nga atong nakuha sa atong FPD. So therefore, pressure at the bottom is just equal to the force exerted by the water, or that is just the weight of the water. that is W of the water, weight na siya ha, and then over the cross-sectional area. Okay, cross-sectional area, diba? Okay, dira man ta sa bottom, nag-ingani siya ba, exert mo siya sa bottom. Okay, kaya atong reference frame kay ang bottom man. Okay, class, unsa may formula for the weight of the water? That is equal to pila man, class? Unsa may formula for the weight of the water? That is equal to the product of unsa man. This is just a review of our topics sa atong forces and motion. Weight of the water is equal to the mass of the water multiplied by the gravity of the earth. Okay, all over the cross-sectional area. But kay man ta, but mass of the water is equal to in terms of density of the and the volume, that is the density of the water times the volume of the water, right? Diba? From our first discussion about density, so diba mao na siya ang relationship between the mass, the density, and the volume. And then kay man ta, class, nga ang volume ani, this is just equal to the volume of the tank. Ba? Volume of the tank. Tungod kay puno man siya sa tubig, so equal pa na sa volume of the tank. And what is the formula for the volume of the tank? That is just equal to the volume of a cylinder. Kay kani nga tank, this is a cylindrical tank. So cylindrical tank na siya. So that's just equal to pi r squared. That is just equal to pi r squared, or ang pi r squared diri is just the cross-sectional area, di ba? Pi r squared, kani siyang a cross-sectional area is just equal to pi r squared, di ba? Let's say na siya radius ang tank nga r. Okay, so therefore we can say that the volume is just equal to the cross-sectional area times the height of the water here. So ang height of the water kay h, so butang ka ACH, and then ato na siya i-substitute ari. So therefore we can say that that is density of the water times the cross-sectional area times the gravity times the height divided by the cross-sectional area. So makancel na siya kay common man. Therefore the density of the water at the bottom is equal to the density of the water times the gravity times the height, or napa siya lang equivalent ini, class. Unsa man siya? Unsa man ning product sa atong density o gravity? That is equal to, sige daw kung naka-remember mo sa atong previous nga discussion a while ago, unsa man ning product sa density of an object multiplied by the gravity? Unsa man na siya, class? Again. That is equal to K, specific weight. So therefore, we can express pala sa density of a certain fluid by just the product of the specific weight of that fluid multiplied by the height. Okay? Multiplied by the height. So therefore, mo na siya ang pressure at the bottom. Now, due to this class, kani ato na derive yung formula, we can say nga ang pressure di ay sa water or any fluid kay just dependent upon the specific weight of that fluid and also the depth, diba? Okay, this mag-vary gud siya aning density sa object, I mean specific weight of the object and the depth. So mo nang gingon class nga, let's say na ako'y drawing ari. So kana siya nga na. Okay, yan ato drawing. So, let's say gifill ni sa og tubig. So gifill na siya og tubig. So I think common na siguro nakakuha na siguro man kinahanglan po ni sa Facebook. So ang let's say natay pressure diri nga P1. Yeah, naputay pressure ari nga P2. Then the same sila, this is water. Okay, water. And then, ang pressure sa P1 is just equal to the pressure sa P2. Ang uban, makaingon nga dako nig pressure because dako kayo volume sa tubig ari. But, again class, take note, nga ang formula for the pressure is just equal to the product of the specific weight of the fluid multiplied by the height of that fluid. So kani siya tungod kay same man ang level sa point 1 and point 2, so therefore same ra pud ilang height. So therefore sila may exert sila og equal nga kanang pressure. Okay, but class, kaning atong nakuha nga pressure, kani siyang kanang pressure sa bottom of this water tank, actually this is just the pressure of the fluid, or we can call this as the gauge pressure ani siya. Okay, gauge pressure kanang ra ni siya. This is not actually the absolute pressure kanang pressure, because just a review, di ba, P absolute is equal to the gauge pressure plus the atmospheric pressure, di ba? I think naman siguro na sa iyong kuan. Now, if ang gauge pressure kay kuan negative, sa may i-indicate na class, if we have a negative kind of pressure, meaning that is a vacuum pressure. So, di ba? Vacuum na siya. So here class, if we're going to find the absolute pressure of this water tank at the bottom, so dili lang nimo yung atong answer kaning specific weight times the height. That is, we need to add pa the pressure that is exerted by the atmosphere, assuming kaning tank class kay exposed atmosphere. So of course namatay atmospheric pressure, so may act po na siya, meaning may exert measured pressure babaw, di ba? May exert measured pressure babaw ana. Therefore we have here P atmosphere. So again, since downward ang pressure, downward po ang gi-exert nga pressure sa tubig, therefore we will add the two pressures. That is the gauge pressure in our example here for a water tank, that is just the specific weight of the water multiplied by the height of the water plus the atmospheric pressure P atm, which is equal to 101.325 kilopascal. Okay, so this is now our absolute pressure. Okay, the absolute pressure, if we have a positive gauge pressure, that is above atmospheric. Okay, if we have a negative gauge pressure, therefore our absolute pressure would be below atmospheric. Okay, so mo na siya ang kanang pag-solve og kanang pressure of a certain fluid that is kanang situated in a certain container. So kanang siya ang container nato ari is the tank. So again, ay kalimti, ang pressure of a fluid is just the product of the specific weight times the height of that fluid. So at any depth di ay class, mag-vary ang ato ang pressure. That is why kung mga dugag Marianas Trench, pag ang pinaka deepest point, dako na kay pressure ngadto, like kumuto na kay mo shrink ka nga to kung wala kay mga kanang protection nga isulot, tungod kay nagkaanam na og ka law. And then the same thing if mga tupog ka sa Mount Everest, di ba, unsa man with respect to the atmosphere, so di ba magkanam kataas pod, meaning magkanam pug kagamay dito ang pressure because wa na po dito ay atmosphere. So mulo imong pressure mao nang maglisod ka ginhawa. And then another thing, ang effect pa dito is that kusog dali ra kayo mo bukal ang tubig kung naa ka sa Mount Everest because ang pressure dito is low. And then siguro sa inyong thermodynamics na subject, ang pressure is associated with temperature. So kung less imo pressure, then mas mutaas ang ubos ang value sa boiling point sa atong fluid. So mao na siya. Okay, any question regarding aning principles kaning upat: density, specific gravity, and specific weight and pressure? May pangutana? Nasabtan ra? Okay, so let's proceed to some examples kung wala pangutana. Okay, so nalata diri. kani siya common gini siya nga problem in fluid mechanics. So we have here a system as you can see in this figure. So this is at 20 degrees Celsius. Actually kaning 20 degrees Celsius man siya ang standard temperature for engineers. So naa mo gani say ko nang kuan pod para ilahi po ning mga engineers so nasa po sila standard. So standard temperature ang gigamit sa engineering is 20 degrees Celsius. For physicists, that is 4 degrees Celsius. Okay, if atmospheric pressure is 101.33 kilopascal, okay, kaniyang gi-indicate mo na siya ang free surface sa tubig, free surface sa water. Of course, natay exert dira nga pressure sa atmosphere. So ato sa i-label nga PATM. Okay, so natay pressure ara ha. So what we need to do here is we just sum up the pressure sa gikan sa babaw padung ubos. Okay, padung mata sa ubos. And then kingan diri and the pressure at the bottom of the tank is 242 kilopascal. So asa ni siya? Naa diri kaning ubos. Ato indicate ngadto ana mo na siya ang pressure sa bottom. So ato ibutang indicate that is P bottom is equals to 242 kilopascal. So see, diri sa surface kay atmospheric ra pag-abot ngadto dako na kayong value sa pressure tungod aning mga fluid. So diri kas naatay kuan multi system ta because we have kanang several fluids nga present ani. So don't worry, ikabala ka kay kanang ato ra sundon ang kanang kuan principle sa pressure. So ang pangutana is, what is the specific gravity of fluid X? So we have a fluid X located between the water and mercury. So we can say nga si fluid X is bugat ni water. So unsa may expected nato sa value aning specific gravity aning fluid X? Is it greater than 1 or less than 1? Unsa man kas? Okay, greater than 1 because bugat siya ni water. So ato isuwat ang requirements niini. The required here is the specific gravity of the fluid X. So that is Sg of X. Okay. Then solution. Now, if ingani ang case class ha, ingani ang case, ingani gali ang figure or data. Actually ang pag-solve sa total pressure at the bottom, so the pressure at the bottom class is just the sum of the pressures gikan sa babaw padung ubos. So man siyang pag-deal og mga kanang kuan pressure nga mga problems. So let's say atmospheric na exert ngadto, that is PATM. Pati pod ni si SAI-30 oil. So exert pod siya, that is P of the oil lang ato ibutang. Of course si water exert pod siya og pressure, PW. And then of course kani si fluid X may exert pod siya, that is P of X. And then finally si mercury, P of Hg. Okay, na-gets ra ninyo? Now if we're going to sum all these pressures, of course that would equal to the pressure sa bottom, di ba? Na-gets niyo idea? Mo man siya ang pressure pod kay the same with the forces. Now kung natay forces padung ubos, so imo na i-sum up mo na siya ang total force nga ma-experience nimo in that particular location. So here mo po ni the same thing. Daghan kag daghan kag mga fluids nga nag-exert og pressure sa bottom. So therefore you just sum up the pressure that is exerted by every fluid. So mo na siya ato na i-sum up. So therefore our solution would look like this. That is the pressure at the bottom is just equal to the pressure sa atmosphere plus the pressure sa saing nga oil plus the pressure of our water plus the pressure of our fluid X plus the pressure of our mercury. Okay, we all know the value of the atmospheric pressure that is given in the problem, that is 101.33 kilopascal. So isuwat nato 101.33 kilopascal. So here mara gini ang ato ang problema pod sa pag-solve kay ang units. So ay pataka og kuag units convert or ayan na siya yung left behind. Dapat uniform atong units niya. Okay class, again unsay formula ratuod sa pressure? Sa to itong formula nga na-derive ganiha, pressure at any type of fluid, that is equal to pila to class? Unsa to ikuan? Unsa to formula? Kinamdom mo? Specific weight times gravity? Or specific weight times another parameter? Kay kumingkag specific weight times gravity, then mas square na po, di ba, ang specific, okay, times height. So, okay, sakto. So, that is the specific gravity. So, that is the specific gravity of oil times the height of the oil. So, nata diri H sa oil. Okay? Plus, here, the specific weight of the water times the height of the water plus the specific weight. So, times the specific weight sa kanang fluid X, then multiplied by the height of the fluid X plus the specific weight of the mercury Hg multiplied by the height of the mercury Hg. So here, as you can see class, walay gihatag ng mga unsa man, walay mga ipanghatag ng mga constants ari for the mercury and the oil. So mo nang bantay-bantay mo, and since na-memorize na po rin ako ang value, so for sa E30 oil, ang density ana niya is equals to 880 kg per cubic meter. So see, mas gaan siya kaysa sa tubig. How about for mercury, sir? So for mercury, that is Sg, Hg, abbreviated as Hg. So Hg na siya. Ang mercury kay Hg, kay ang water kay H2O man. So mercury Hg, the density or specific gravity na lang. Specific gravity, that is Sg of mercury is equals to 13.6. So kana nga useful information, then nakaibaw na ta. So again, we're going to write it again. So 101.33. So since class kay ang atong required ani kay ang Sg man, kay Sg man, and then atong mga given po dra kay naraman tayo mga density. So therefore, aton lang ning ipang convert ning specific weight into into densities. Okay, specific weight into density. So therefore, kaning specific weight of oil, this is just equal to the density of the oil multiplied by the gravity, then the height of the oil, plus the density of the water multiplied by gravity, then the height of the water, plus the density of the fluid X times gravity times the height of the fluid X, plus this one is the density of mercury times G multiplied by the height of the mercury. But we all know class that, diba? We all know that the specific gravity of an object is just equal to the density of the object over the density of the water. So therefore, we can rewrite this one as the density of the object pala is just equal to the specific gravity of the object multiplied by the density of the water. So ato na ipang substitute for every object here. So natay lain nga objects, natay oil, natay fluid, ug natay fluid X ug mercury. So mao na itong gamiton para makakuha na ta og kanang makakuha ta og maka-substitute din ta kung sa given nato. So therefore, this will make into 101.33 kilopascal. So that is kilonewton ato is what? Kilonewton per square meter. Plus, kaning density sa oil class, di na nato siya i-convert into di na nato siya i-convert into Sg tungod kay given naman tawag density sa oil kani 880, so therefore remain na lang siya at as it is. That is density sa oil, G H sa oil, plus for water, since kiba naman ta, so ano na ito i-convert into SG. Density sa water, G times HW, plus since kani density sa fluid X, since atong ipangita is the SG of fluid X, so therefore required ta ani ato i-convert into kana density in terms of the SG. So that is SG sa fluid X, then multiplied by the density of the water, then the height pud ana nga fluid X, plus for mercury, since ang atong given kay SG man sa mercury, so ang kaning density sa mercury ato na siya i-convert into into its specific gravity and the density of the water. So that is specific gravity sa mercury multiplied by the density of the water times the times the gravity pa, times the gravity times the height of the mercury. Okay, so kaning atong atmospheric pressure class, mas better nga ato na siya i-convert into newtons tungod kay para ma-uniform siya sa the rest, because ato mo gani i-prove ning ang kung mag dimensional analysis ta aning pressure, that is density times gravity times the height. Ang answer gidan siya in standard is, this is kilogram per cubic meter, then the gravity is meter per second squared, the height is in meter. So kung nyo makita, equal na siya sa man kani siyang kanang kilogram meter per second squared, that is just equal to the newton, right? Then this one is cubic meter man siya, kuhaan og meter usa, that is newton meter squared. So therefore kaning mga pressure sa atong oil, sa water, sa fluid X ug sa mercury, ang iyang units ana is in newton meter squared. So therefore kaning atong atmospheric na kilonewton ato lang siya i-convert into newton. So that is equal to, multiply na to 1000, so that is 101,330. So that is 101,330, that is in newton meter squared. So consistent na ni siya sa the rest ng mga pressures. Again, substitute the values. Density of oil nata diri, that is 880, so 880, then kilogram per cubic meter. The gravity is 9.81 meter per second squared. The height of the oil glass, unsa may height sa oil diri based sa ato ang figure, pala may height sa atong saing 30 oil. Okay, 1 meter. So butang ta 1 meter. Plus the density of the water is 1000, right? 1000 kilogram per cubic meter multiplied by the gravity 9.81 meter per second squared multiplied by the height of the water, ani, diba? 2 meters based on the figure. That is 2 meters, and then plus SG of the fluid X, we don't know, mo na ang unknown, times the density of the water, that is 1000 kilogram per cubic meter multiplied by napalay ni G diri, acceleration due to gravity, that is 9.81 meter per second squared, then multiplied by the height of the fluid X, that is 3 meters, then plus the SG of mercury is 13.6, so that is 13.6 multiplied by the density of the water 1000 kilogram per cubic meter, then the gravity 9.81 meter per second squared multiplied by the height of the mercury is 0.5 meters. So 0.5 meters. Okay. And then kanipod, since ang pressure sa bottom is 242 kilopascal, so at so today that is 242 kilopascal, or that is in kilonewton per meter squared. So the same with the atmospheric pressure, ato siya i-convert into newton per meter squared. So we are going to multiply that one by 1000. So that is 242,000. So nato diri 242,000. So that is Newton per meter squared. Okay, so I think consistent na ta because ang result po dire kaning mga units ari sa ato ang mga fluids kay in Newton per meter squared mo po ni siya, in Newton per meter squared. So therefore we only have one unknown, the SG. So ang sibato na to ato na pang transpose to mga values. So to simplify, 242 equals 101,330 plus ang oil kay 880 times 9.81 times 1, that is 8,632.8, then plus ang sa water 1,000 times 9.81 times 2, the answer is 19,620. So 19,620 plus, okay na i-join, wait lang. Okay, so 19.620 mo na siya sa tubig. Then sunod kay si fluid X, so mo na tong unknown. So for fluid X, that is just 1,000 times 9.81 times 3. So the answer is 29,430 times the SG. So 29,430 times SGX mo na unknown. Plus the mercury, pinaka-last, 13.6 times 1,000 plus 9.81 times 9.81 times the height of 0.5. The answer is 66. So 66,708. This is in Newton meter squared. So kani siya ato ni transpose the constant, combine the constant on the other side. So we now have the value of our specific gravity for our fluid X. That is equal to 242,000 minus 101,330 minus 8632.8 minus 19,620, then minus 66,708, then all over ato i-divide sa kanang constant or coefficient sa SG. Okay, the answer for our SG of fluid X is just approximately equal to 1.55. So SG wala na units because that is just the ratio of the density of your object with respect to the reference value of our density, which is the density of the water. Okay, masya ang SG, and we can say that the SG of fluid X is indeed greater than 1 because mas bugat man siya sa tubig. Okay, any question? Naipangutana regarding our first example for pressure. Wala pangutana ni? How about the others? Nakuha ra, nasabtan ra? So kung wala pangutana, then let's proceed to the next problem for our topic 1. Okay, so again, same ra gihapon, nagyapon tay kanang kwan system ari. So in the figure daw, kanang kwan, both fluids are at 20 degrees C. So standard atong gamiton ani nga mga constant. Now if surface tension effects are negligible, so meaning walay mga forces nga nag-act between the surface of the fluid and also the surface of this container. Now, unsa na ko density sa oil in kilogram per cubic meter. So here, mo na itong oil, nagpatong siya sa kanya itong tubig. So I think di kayo makarong tubig, mo na yung tubig. Mo na yung tubig, na siya sa bottom, then nabot siya nga to sa babaw. So until diri nga point. So manang gilibelan siya nga. Sa other side, ang tubig kay hingray siya og 6 cm with respect to this sa iyang previous nga height. Okay, so we are going to to write the given, including sa katong mga constant. So here, we know that the density of the water is equals to 1,000 kilogram per cubic meter. And what else? Of course, kani siya, since this one is open, so open ni siya, magkabutang puta dira og unsa man, atmospheric pressure. So P ATM. Open man siya. And the same thing on the other side. Nahapon ni siya atmospheric pressure nga hing exert. So therefore, both sides of this U tube kay naay kuan atmospheric pressure. Okay, given and then required. So ang required here is the density of the oil. So that is density of the oil. Okay, so solution. Diri a class is ang kuan ni class dagay pa maagi ni. The first one is that is kuan kanang dali siya, that is kanang mag-set ka og kuan. The first thing you should do is set your kanang starting point. Set starting point. Let's say we considered here this one, the left side, as our starting point, that is point A, and then the right side is our finishing line or finishing point, point B. So set starting point, point A ta. Muna ang first nga pamaagi class ha, pag solve og mga ingani nga mga systems. Okay, so maguna ka sa A, then after that ato pod i-kuan class, ato pod i-define ang point, ang pinaka bottommost point. So in this system, di ba, ang pinaka bottommost point kung asa ang pressure dako kay diri, di ba? That is point C, di ba? Diri man kay siya nga line. Mo siya ang pinaka bottom nga part, so at point C. So to solve that one, that is the pressure gi-exert from A to C. Okay, that is positive. And then kung mga to na pug ka from C to B, mag-negative na pud siya. Okay, mag-negative siya. Why? Because ang kanan ni siya, ang basic ni kay down positive. Kung mo rise na pug ka, so kung mo rise ka is you're dealing against the pressure of this fluid, so therefore that is negative na. So that is minus P pressure from C until B. Okay, that is equal to 0. Okay, sum up to 0. Mura na po siyang summation of forces class, because kung ato siya i-rearrange, that is just equal to the pressure di from A to C is equals to the pressure from C antud sa B. Unlike sa atong previous example nga usa ra man gud to class, diba, usa to kay ana. Of course tungod kay pa-down naman tanan, kinara man ang bottom, kani kay mi ana man gud ni miu man gud ni, meaning na siya kagawsan nga atmospheric condition ba diri. So therefore ato isama kung unsa gi-exert nga pressure padung sa bottom, mao po na gi-exert nga pressure sa pikas. Kay kung di na pareha kay mulamos ni ang tubig ari, mulamos ang fluid ari. So did you get the idea? That's why naka-come up ta og kanang equation nga ang pressure from A to C at this point, man siya i-insert dira, is equal to the pressure pod sa pika side from B to C. Mo ni siya B to C, because they remain into a static kanang kuan equilibrium. So man siya ang kanang kuan pamaagi pag solve og ingani nga mga kuan. Actually na po ibang mga problems nga ingani siya style oh. Dagan na siya kuan, dagan siya liko-liko. So ingana. O ingana. Ina po buhatan ini is kuan mara gito. Yung buhatan that is wag gamit na tong kuan tungod kay daghan naman kanig liko-liko, morning ang down kay positive, then kung up na pud ka against the pressure negative, then down positive, this is positive, then kani siya kay negative kay against mo ka, then padung na pud ngadto kay negative na pud, then padung na pud diri positive na pud, padung na pud ngadto negative. Ang summation ani kay 0. Okay, So nga na pagdilog may nga mga problems. Anyway, masugatan gid ninyo sa inyong kanang fluid mechanics. Okay, so here since usa man ka kaliko, usa man ka turn, so therefore ang equal ra ang pressure from A to C is equal sa pud sa pressure from B to C. Okay. Since kay bao na biyata sa pressure from A to C, di ba? That is just equal to so may pressure nga nasa A, that is atmospheric. So what? P atmospheric plus unsa man nga fluid kaning diri, that is water. Unsa may kuan sa water diri, unsa may height niya, that is 6 gikan ari padong C pilay height, that is 6 plus 10, di ba? Kani 6 plus 10, so that is density sa water times the gravity times the height of the water from A to C. Ito na sa i-label sa is equal to, how about the pressure here from B to C, that is nagyab siya atmospheric, so P atmospheric then plus the pressure ani nga oil, kay kani kaduha nga fluid kay oil naman siya, that is the density of the oil multiplied by G times the height of the oil, diba? The height of the oil plus kaning remaining nga height from this point, ang pinaka lowest point sa oil padung sa letter C, point C, ang height sa tubig kay 10 cm, so that is the density na pod sa water, the gravity times the height of kanang the water here, HW na lang. Okay, so as you notice class, kaning atmospheric pressure both sides of the equation makancel na siya. Okay, since mao man ni atong ipangita density sa oil, then ato na i-transpose ni siya. Okay, so we have now density sa oil is just equal to the density of the water times the gravity multiplied by height sa water from A to C minus height sa water sa pika side all over the gravity times the height sa oil. Cancel ang gravity, so plug and play na siya. We all know the density of the water is 1,000 kg, that is 1,000 kg per cubic meter multiplied by the height of the water from point A to point C, that is 6 plus 10, that is 16 cm. I-convert na into meter kay para consistent sa density, that is 0.16 meters. Okay, and then minusan pa day, minusan pa rin nato sa height sa water gikan sa lowest point sa oil padong sa letter C, that is 10 cm, that is minus 0.1 meter all over the acceleration due to gravity is 9.81 meter per second squared multiplied by the height of the oil is 8 cm, or in meter that is 0.08 meters. So here ang meter sa babaw makancel na po dari, and then okay, sorry, wala din ni G kay na-cancel naman dahil nasuwata naman noon, so wala din ni G. Okay, so makancel ang meter sa babaw, makancel ang boss. Okay, so ang atong final nga unit is kilogram per cubic meter, which is okay kay ang density kay in terms man ana. Okay, the density of the oil is therefore 1,000 multiplied by 0.16 minus 0.1 divided by 0.08. So the answer is 750, that is 750 kilogram per cubic meter. So mana siya density sa atong oil. Okay, naipangutana. Naipangutana class? Naipangutana wala? Okay, so kung wala pangutana, then let's proceed to the next topic, which is all about viscosity. So kaning viscosity class, this is the property of the fluid. Okay, the property of the fluid to resist this is the property of the fluid na may idea ni what is viscosity. Okay, so sakto, that is the property of a fluid to resist the flow of itself, especially kung may mga external mga forces, so it resists flow. And then of course mapunay magdetermine sa kanang kuan how sticky kanang certain fluid. So let's say ang honey o ang water, so asa may mas viscous, viscous, ang honey or ang water. So diba honey is viscous than water, because kung imo na siya iyabo, dugay kayo mo yabo ang honey kumpara sa tubig. So mara siya ang kuan sa viscosity. So mara siya ang resistance sa usa ka kanang fluid in motion. So mohinay siya tungod aning iyahang property nga viscosity. Now for viscosity class, natay duha ka types sa viscosity. So two types of kanang viscosity. So the first one mo na gitawag nga kanang kuan dynamic or absolute. Dynamic or absolute viscosity. Then ang ikaduha kay kanang kinematic. Kinematic viscosity. Okay? So ang kuan man daghay gamit aning kuan. Importante pud nga makat-on-town sa siyang viscosity, since gamit kini siya especially if we're dealing with lubricants. So kanang mga lubricants atong gamit sa motor, sa sakyanan, naran siya specific nga value sa iyang viscosity para maka-achieve siya sa iyang kuan, sa iyang purpose. Diba ang lubricants is to reduce friction. So nana siya degree of kanang sana ang iyang kuan ba, iyang kalapot, para makakuan gyapon siya, makalubricate siya sa parts, and then kuan po na siya mo act as a cooling system. So di po siya mainit dayon, because viscosity is also associated with temperature. So ato ni i-derive ang formula for the dynamic viscosity or absolute viscosity. Okay, for this let's say naatay kanang reference nga surface, and then kani nga surface class natay fluid ana nga nag-move. So fluid ha, kani nga fluid ato gi-assume nga kanang assume na to ang fluid kay incompressible, and then natay plate ari. Okay, natay plate ari. Okay, so here if we're going to apply the force, let's say kung ang mag-apply tag force adto, meaning dinhi mo spread out ning fluid nga nasa sa ilahom ha, kay kan siya incompressible man so if we apply a force here, so diba ang fluid nga mistake ari sa ubos class, of course di na siya move kay kanang of course it possess certain viscosity, so therefore mupugong siya og move. Ang diri sa top part madagit gid sa kaning flat plate, tungod kay himpilit man gud pud siya dira due to some kanang forces like adhesion of kanang cohesive force. So here kung inyo ma-notice, kung ato na i-move, so let's say move siya, so it has a certain velocity v. Okay, sa inyo class, tungod kay hingpilit ni siya diri, meaning ang velocity ari sa ubos kay mas hinay compared sa babaw. Mo agree ba mo? Kay diba wala man siya nag-move, dira man ta nag-move sa surface, so therefore kusog kani velocity ari. Marabag in a circular motion, diba? Kato na i-move nga to, mas dako kay linear velocity compared ko naka sa dool, diba? So the same thing with this. So here, I hope nakita mo sa video sa stress. So ang na-experience sa ato ang fluid ari, na-stress siya sa kaning part. Kaning upper part, na-stress siya. Diba, ang tawag sa ang type of stress nga na-experience sa atong fluid, ang type of stress kay shear. Anong shear man? So assume this is the cross-sectional area AC. This is shear because the force acts parallel to our cross-sectional area. Okay? So kung naatay shearing stress nga nahitabo sa atong fluid, then we can say that tau, or the value of the shearing stress is tau, or we can say tau is equals to force all over the cross-sectional area. Okay? And then, kung ano po class, napod tayo lain nga kanang principle nga makita na ni. Now, kung inyo ma-observe class, kung ato ni i-move ang plate, of course, natay velocity nga ma-experience sa upper part, which is very large compared sa velocity nga himpilit diri sa bottom. And then, kung ato ni butang distance between the plate above the fluid with respect to this ground, let's say y na lang ni siya, di na nato i-h, y na lang, say y. So tungod kay mag-vary man ang velocity, so mag-drawing ta diri, meaning kung mag-drawing tag diri, ang velocity vector quantity, velocity sa ubos gamay, nin hingkanam siya ka-increase as it goes higher and higher until mo reach sa surface. So ang velocity sa surface mas kusog compared sa ubos. So therefore, we can say that there is a relationship between the velocity and the height. So we can say that there is a gradient nga na form ani tungod kay as y increases, or the gap between the fixed plane and the flat plate mo increase, so may increase what ang velocity. So therefore, we have a gradient of the derivative of velocity with respect to the height. Okay? So ang change na niya is what is known as the velocity gradient. So velocity gradient dy dv over dx. So here, makakuanta nga si force di, ang force nga itong gi-exert sa plate is just directly proportional with the area, and then the derivative of the velocity with respect to y, or the velocity gradient. And then since kanang naman tayo kanang relationship ni ini, so dapat kung ato ni i-convert into equation, then dapat mabutang taog kanang mabutang taog proportionality constant. So unsa nang proportionality constant ari, that is just equal to our dynamic viscosity. So mo nang nabuhi ning dynamic viscosity, and then multiplied by the cross-sectional area times the velocity gradient. And then kung ato ning i-divide by the cross-sectional area both sides, then ato pod na prove class nga ang shear stress kay na-experience good, because we all know that the force over cross-sectional area is equal to the shear stress tau, that is mu. So mu ni siya times the velocity gradient all over the height. Okay, so here, since na naman tayo formula for our mu, that is mu is equals to the shear stress all over the velocity gradient, then ato kitaon kung unsay units sa ato ang dynamic viscosity. So dynamic viscosity, kung atong makita sa ato ang stress, diba? Ang stress is unsa may dimension class sa atong stress. Unsa may dimension class sa atong stress? Are you still following with me? Follow pa mo? Sa may dimension. Di ba nga tong stress is mao pa na siya ang pressure nga na-exert nga gi-exert sa atong kwan, sa ato ang mga solid nga mga materials or even liquids. So ang stress is associated with pressure because stress is also the ratio of the applied force over the cross-sectional area. So therefore ang dimension sa ang stress is force is in Newton, or that is in kilogram meter per second squared, and then multiplied by the area, that is meter squared. While the velocity here is in meter, then second, multiplied by the dimension of our y, which is the gap between the reference plane and the flat plate, that is meter. So kanit siya makancel ni, makancel ni, and then kanipod makancel, mausa lang ni ari, and then kanit siya kay ma-bring up, so makancel ni. So therefore ang expected nga dimension sa ato ang dynamic viscosity is kilogram, then kani siya ma-second, usa lang ka second, so that is kilogram meter second. So mo na siya ang expected nga kuan dimension sa atong dynamic viscosity. But sa dynamic viscosity pod class napod siya other nga kan dimension, because the kilogram meter per second class pwede po na siya ma-rewrite as Pascal second. Pascal is the unit for pressure multiplied by second. So ato da i-prove ngano ang Pascal second kay equal ni siya sa kilogram meter kanang kilogram per meter second. Pascal is in kilogram meter per second squared per meter multiplied by second. So kita meter squared man ni, so cancel meter ma-second na ma-cancel, therefore that is kilogram meter second. So sakto ra gihapon. Again, other units for dynamic viscosity is Pascal second, or sa English pa this one is poise. Gamit po sa aning poise. And then ang poise, ang relationship between kanang kuan Pascal second ang poise, that is one poise is equal to 0.1 Pascal second. I think puwa mas siguro ni puwa pagbasa puwa no puwa okay. So sunod way pangutanan ni so walay pangutana, then proceed ta sa kinematic viscosity. So sa kinematic viscosity class, ang formula for kinematic viscosity, this is just the ratio of our dynamic viscosity over the density of the fluid. So ang kinematic viscosity abbreviated as kaning V. Mura po siya velocity, pero iya mo kalibot. So kana siya bold nga letter V is equal to the ratio of our dynamic viscosity, so mu all over the density of the object. So pwede na ito butangan na mu sub O. So dynamic viscosity of the object all over the density of the object. And then kung ato kitaon ang iyahang units niya, so for dynamic viscosity, that is again kilogram per meter second. How about for density? That is kilogram per cubic meter. Okay? So ang kilogram makancel na siya, then ang kani meter squared na ni makancel sa usa. So therefore ang unit sa atong kinematic viscosity is meter squared per second. So mo na siya ang units tong kinematic viscosity, and then napud tay relationship sa atong kuan sa ato ang kanang kinematic viscosity. So kaya ang kinematic viscosity class is not only limited to this dimension. Other dimension for kinematic viscosity is Stokes. So apelyido ni siya sa sikat pod nga scientist nga nag-discover mga principles of fluid mechanics, si Neville Stokes. So naay conversion ani from Stoke to this meter squared per second, because 1 Stoke is equal to 1 cm squared per second, or kung ato na i-convert into meter, that is 0.001 ato check ha, verify na to. 1/100 squared, I think tulo di ay 0.0001. So ato i-erase usa mo siya yung conversion, 0.001 meter squared per second. So man siya importante nga mga conversions. So again, ang kalahian sa dynamic of kinematic viscosity is that kinematic viscosity is kanang na siya'y parameter nga gi-divide, which is the kanang density. So nag-differ ra siya sa density sa object. So for dynamic, mo siya in terms of Pascal second or kilogram kilogram per meter second, or you can use the poids nga kanang measurement, and this is for English or imperial unit. And then on the other hand, for kinematic viscosity, that is in meters squared per second. And then you can also have the Stoke imperial unit gihapon na siya, and then mo na siya atong conversion. 1 Stoke is 1 cm squared per second. So mo na siya anyong tigaman for the viscosity. We have two types ra, dynamic and kinematic viscosity. So nay pangutana regarding ani. Pangutana class. Wala na? Okay, so let's proceed to Reynolds number, because Reynolds number is also associated with viscosity. Ang formula sa Reynolds number magud kay na siya viscosity. So Reynolds number, familiar na ba man ni Reynolds number? So ang Reynolds number abbreviated by this RE. Okay? Ang Reynolds number, this is a dimensionless number. So gamit kani siya. Dimensionless number ni siya. Dimensionless number. So in fluid mechanics class, daghan kay magmasugatan nga dimensionless number. Even sa mga heat transfer, daghan kay na siya. So usa nila is ang Reynolds number. So ang Reynolds number, this is the ratio of your inertial force all over the viscous nga force. Okay, unya unsa may purpose ani sir nga nang mag-study og Reynolds number? Reynolds number, ang importance niya is kanang kuan siya. It is used to determine the type of flow of our fluid. Okay? Because ang kaning ato makuha nga value for Reynolds number, we are going to evaluate this by using these three criteria. So kung atong Reynolds number kay less 2,000, ang pag-evaluate ani is that the flow, since kon siya mo determine siya sa type of flow. Okay, the flow is laminar. Okay, unsay pasabotan ning flow laminar. So kung na may faucet sa inyo, kanang nindot og style nga faucet, then inyong paagasan og hinay, di ba nindot kay kanang maka-try mo nindot nga flow nga di saba, hinay kayo. So man siya ay laminar, meaning ang let's say kung ato i-drawing class, ang streamline niya, let's say kaning flow sa tubig, straight gid siya, laminar jud kayo, like hingfala gid siya. So manang object mana siya maliko ana ra pud siya. So laminar kayo ang flow class, walay mga samok-samok, mana ang laminar. However, if our value of our Reynolds number is between 2000 and 4000, ang mana siya gitawag nga transition zone. So flow is in transition. Say pasabot sa kanang is in transition, meaning mo change na siya from laminar to ang kalas mo kay turbulent. So flow is in transition. So dapit-dapit laminar, dapit-dapit kanang turbulent. So or mo change siya tungod kay ang value sa Reynolds number nga 4000 to positive infinity, higher number, ang flow nato kay flow is turbulent. Unsa may mga turbulent flow? Kana magsakay ka og motor nya hangin kaayo, kana naka-experience ka og turbulent flow, kana mag-open ka og gripo nga gubaon na pud nya, paspas kusog kaayo ang pressure, kusog ang kanang discharge, turbulent gyapon na siya. So for a turbulent flow, wala siya harmony sa iyang streamline. So kani siya mga streamlines ni siya. This one are streamlines. For turbulent flow, ingano na siya nakatag-katag. So nagkatag-katag siya, katag kaayo. So walay fashion, walay harmony sa atong streamlines. So mo na siya class. Mo na siya ang important sa Reynolds number. Now ang pangutana ni is unsa may formula ani sir sa Reynolds number? So for Reynolds number, ang iyang formula magbase ta sa kanang iyang gitawag nga inertial force and viscous force. But actually, ang derivation niya is inyo siya masugatan ka sa iyang fluid mechanics na subject sa part nga katungkuan backing hampay nga equation. So inyo na masugatan. So Reynolds number RE is just equal to the velocity, okay, that is equal to the density times the velocity, okay, velocity times the diameter all over the dynamic viscosity. So again, this one is the diameter. So ano na may diameter sir? Because in a certain type of flow dapat naka-i-assume na diameter. Let's say this is a pipe. Okay, pipe. Then of course natay flow ana sa tubig. So therefore natay D ani, di ba? And then kani siyang flow, of course natay velocity ani V, right? And then since this is, let's say this is a fluid, so it has a property which is ang iyang dynamic viscosity. And of course naputay density sa ato ang object or fluid. Okay? So, mo ni siya, this is dynamic viscosity. Okay, dynamic viscosity. And then of course the density. So, basically mo na siya ang Reynolds number, but ang Reynolds number pod can be expressed in terms of kinematic viscosity. Why? Because we all know that the kinematic viscosity V is equal to the ratio of our dynamic viscosity over the density. So from Reynolds number, we can rewrite this as the velocity times the diameter all over the mu. Then ato ni bring down ni si density sa ubos, so that is mu over P. So that is just equal to the velocity multiplied by the diameter all over the kinematic viscosity V. Muna siya ang inyong gamiton to solve for the Reynolds number. Now, kung hataga mong situation nga kanang naay flow sa fluid, and then ipa-evaluate mo kung unsay types of flow, whether this is laminar, in transition, or turbulent, then you can use the formula for the Reynolds number. So that is just the density, kinematic viscosity, density times velocity times diameter all over the dynamic viscosity. Now, since mingin matanga, this is a dimensionless number, ato i-prove kung dimensionless begin ni. Okay, so for Reynolds number, that is equal to the density, ang dimension sa density is kilogram per cubic meter. Then the velocity is meter per second. The diameter is in meter. Divided by the dynamic viscosity is kilogram per meter second. So 9 kilograms sa babaw na pud sa ubos. Meter dire, meter times meter, meter squared. However, kung ato ni siya ibutang sa babaw, di ba? Mahimo na po ni siya og meter cube. Itong kinamatay meter sa ubos. So meter cube makancel ari. Then mawa ni siya kaya ito man gi-convert. Then natay second sa ubos sa fraction, napatay sa denominator nga naka-fraction, so that would be cancel out. So unsa man habilin? Wala. So therefore ang atong Reynolds number is a dimensionless number. So ato gyud na prove nga dimensionless number na siya. Okay, pangutana regarding ani. Nay pangutana class? Sabtan na? Nay pangutana? Wala na? Okay. Kung wala pangutana, then let's proceed to the next one. So, nanata sa surface tension. So, ang kaning surface tension class is kanin siya. Muna siya ang kanang kuan ba? Ang kapiliton sa kanang surface sa usa ka fluid nga mo stick siya sa other surface sa kanang kuan other object. So kabantay mo anang nasa sapa or sa mga swampy area, di ba? Kabantay mo na insekto nga mo kuan makalakaw sa tubig. Nakakuan mo na. Okay. So muna siya usa sa kanang atong makit-an surface tension in a real world and even sa kanang paglaban ninyo. So the reason nga nung mogamit ta og kanang detergent is because atong gipa decrease ang surface tension. Kay kung increase ang surface tension class, di ba kay ang surface tension kay ang unsa kakapit ang tubig or ang fluid sa other objects nga na suspend niya. So since atong gihumo lang ato ang sinina sa tubig, so kung imo na kusok-kusoon na chance nga masamad imong kamot tungod kay kapit ang tubig sa imong sinina and even in your hands. So kusog pod ang friction tungod kay magikusok-kusok, so therefore kadali ra ka masamad. And then another thing is ang mancha or mga lapok or unsa pa na nasa sinina. Now kung walay detergent, lisod na ko on why, because stick na siya tungod ang tubig pod mi stick niya, so therefore kusog kayo ang adhesive force. So mo na ang detergent gi-apply siya tungod kay gi-lower niya ang surface tension sa water. Maunang kanang smoother kayo, di ba? Kung maglaba ka na sabon, di ba? Dili sakit tungod kay danlog. So ang kuan ng danlog is wa na pilit ang tubig sa imong sinina or even sa imong kamot. Mao nang di na ka masamad. Okay? Na-gets rin ninyo? And then even kanang magbutang og needle sa surface sa tubig. So tungod kay ang needle kay na siya considerable na characteristic sa iyang surface, so metal siya and then gamay po kay siya. And then kung ang tubig mo kay na siya surface tension, so manang kung imong hinahinay butang ang needle, then murutaw siya. Pero kung imo na pud siya sabdon, so muhinay naman pud ana ang surface tension, so meaning malunod na pud siya. So mao po rin hitabo sa kanang insect na mulutaw sa tubig. So tungod kay ang ilahang mga feet, kanang ilahang mga legs kay kuan na siya kanang kuandera characteristics nga mo increase ang surface tension, then mo na makalakaw gid sila. So for a surface kanang class surface tension, this is just the class, the ratio of the force all over the unit length or distance. So force over L na lang ta. So let's say in this drawing class, let's say naatay surface, assume lang nga naatay surface ari. And then of course ang tubig kay na po dira, diba? Ang tubig mipilit ana ang surface. So unsay kanang value sa atong surface tension ini. So ang value sa surface tension, that is just the ratio of the force over the length. So let's say ang atong length ari, ang length of contact ha. So the length of contact mo na siya L. So kani siya length of contact between the fluid and the object. Length of contact. Then of course ang force nga naa nila. So man siya gitawag nga adhesive force. Adhesive force. So man na siya ang force nga may act between the surface of the object and the surface of the water. So kani siya, let's say this is H2O or tubig. So naginay force nga nag-attract nila. So that is force, then also the force of the surface. So what is the magnitude of the surface tension in this example? So kani siya natay tubig, certain length. So therefore the surface tension here ato ay abbreviate as capital letter T. So the surface tension is equal to the force all over that length. So if we have a force of kanang 10 newtons over 2 meter nga distance or 2 meter nga contact, that is 10 over 2. So that is equal to 5 newton per meter, meaning na ay 5 ka newtons kada meter nga may exert between the water and the surface of the object. Now let's try to solve for the surface tension sa mga let's say sa atong baso, common mo na siya, baso planggana. So as you've noticed, unsa may surface sa atong baso planggana, or even sa atong mga mineral water, diba, that is circular. Diba, that is circular. Okay, so nadira ang tubig, let's say tubig ni siya, tubig. Okay, tubig ni siya H2O. Kani siya is kanang edge of sa ato ang glass. Okay, edge. So therefore ang atong tubig mi-exert siya og kanang adhesive force sa ato ang edge sa ato ang glass. Of course si glass pod mi-exert pod siya og kanang equivalent force. Of course action and interaction, and action and reaction. So kana siya unsa naman class, since natay force ara, natay uniform force throughout this throughout the edge of the glass. So unsa naman natong length ni class? What is now our contact length of contact, assuming that the geometry here is circle? Sige daw, unsa na may formula sa atong length ari? That is, unsa man? Unsa man class? Circle naman siya, circle na siya. Again. Putol. Otro. Remember class, circle ni siya. Okay, 2 pi r, or the circumference, right? The circumference of the circle. So the length of contact here, since circular man siya ay shape. So L is just equal to the circumference. So that is 2 pi r kung ano siya radius. Okay, so therefore ang value sa atong surface kanang tensioner is just equal to the F all over 2 pi r. So this is for circular nga surface. Okay, so more na siya ang ato ang kanang surface tension. And then usa sa mga example sa surface tension class is ang ato ang capillary tubes. So sa wala nakafamiliar sa capillary tubes, kanang atong sa dextrose, kanang kuan dextrose kasi diba naman mga kanang small tubes. Then ang usod anang small tubes is of course ang mga ang fluid nga nagdaog mga kuan nutrients para i-fed sa imong body. So kana siya the reason why makatransport gihapon sila og fluid or maka-deliver gyapon sila fluid inside our body bisag gamay jud kay nga hole. Gamay jud kay nga hole. Na siya sud good nga blood or nutrients. Maka-travel gyapon siya kay di ba nabi uban nga ngani mupilit na ang kuan, mupilit na ang atong kuan tubig or any fluid. So kana siya gi-design gina siya nga para mo reduce ang surface tension kay maram gini problema dira ang surface tension man gid man mo block siya sa flow good. Okay, so ang usa sa mga example sa surface tension ang gitawag nga kanang capillarity action. Okay, capillarity. Okay, for a capillarity nga mga objects, so di ba apply din siya sa mga small tubes. Okay, so for a capillarity class, assume nga natay small tube. So mana siya small tube. Okay, that is small tube. And then assuming nga kano siya kay cylindrical na siya, syempre nagi siya sud nga fluid. And then kabantay mo class, I think na nani siya sa inyong chemistry, diba ang fluid ani kay mo ana unsay tawag ani kung mo concave siya pa downward, diba? Are you familiar with meniscus? Katong upper meniscus, lower meniscus, o diba? So assume tani nga kuan siya lower meniscus. So diba for water lower meniscus gini siya kay kung lower meniscus gali ka, so kung lower meniscus gali ang kuan ani is kanang kuan mas taas ang atong adhesive. Okay, magtaas atong adhesive force. So again ang adhesive force man siya ang force nga nag-interact sa ato ang fluid to the object. Okay, unsa may fluid na to ani, let's say this is water H2O, and then atong object kay kaning ato ang cylindrical glass. So ang adhesive force taas ani kay himpilit good si fluid ari, himpilit good si water sa object. Whereas another kanang phenomena pa nga mo occur kay mo to siyang higher meniscus. Sa higher meniscus magyani na siya class. Okay, magburot siya. Yes, nagina ni. Especially sa mercury at in liquid form magyani ang mercury. So kani siya higher ang atong meniscus. So higher meniscus. So meaning ang ato diri kay strong ato ang gitawag nga cohesive force. Okay, so ang cohesive force diay is fluid to fluid nga kanang kuan, fluid to fluid nga interaction. Okay, meaning mas pilit ang molecule sa fluid diri sa usag-usa, mas siya cohesive. So ang cohesive kay ang force of attraction among the fluid molecules, whereas ang adhesive class kay ang ang force interaction between the fluid and the object nga hingkabit niya. So mao siya diferensya between lower meniscus and higher meniscus. Ang higher meniscus class mo occur ni siya sa mga fluids nga dako kayo og specific weight such as mercury or even kanang lead. Ang element nga kanang lead at murag kanang nakamelt siya. Okay? So focus ta sa kaning sa kaning lower meniscus. Okay? Kani siya. Muna tayo example kay mostly magod sa mga problems kay magdili man siya og water. So here mo ni siya ang ato ang capillarity. And then kani siya since naka lower meniscus man siya, di man siya naka lever gun, meaning natay certain angle aning iyahang pagkuan, natay angle ring nga tangent. So ato siya i-denote as kanang theta. Okay? And the same thing pud sa pikas. Okay, natay theta ari. Okay? So di ba kay naman tay effect ani sa surface tension, so aton siya ipatabyo mga class, di ba? Circular man siya. So meaning kada edge, di ba? Kada edge kay nag-exert siya og force, right? Nag-exert siya og force F. And then of course naapot tay gi-exert ani nga surface tension, that is T. Now atong pangitaon kung kanang pilay surface tension aning kanang capillarity tube. And then by summation of forces class, di ba kay namatay force ari, force and then force. And then unsa may laing force nga may exert diri. Another force is this one. Let's say we have a height sa atong kanang tubig. Okay? Another force nga may exert nato sa atong capillary tube is of course the weight of the water. Diba? So therefore, if we're going to sum up the forces nga may interact sa atong capillarity tube along X, along Y, along the vertical direction, then makaderive na ta sa ato ang surface tension sa atong capillarity tube. Okay? So again, mag-drawing tag FBD. So ato point is the water. So may exert nga downward force is the weight of the water. Ang may exert nga force upward is the force due to the adhesion of the fluid to the object, so FA. And then this adhesive force also relates to our surface tension. Okay, so we can say that the summation of forces along the vertical is equals to 0 kay static equilibrium man siya. So therefore, sa niyang mga forces, we have adhesive force minus weight of the water is equals to 0, or the adhesive force is just equal to the weight of the water. Okay, and what is the formula again for tension? So tension, since si adhesive force class kay along man siya sa Y, and then diba ang magnitude sa ato ang force, yun actual force sa surface tension is diba naka-angle man siya, so therefore kanidang force vertical by composition FA is just equal to F cosine theta. So tibutang F cosine of theta is equal to the weight of the water. Now balik ta sa for surface tension, that is T is equals to F all over the circumference of this tube. Let's say ang tube kay na diameter or na ay radius r lang, that is F all over 2 pi r, or the circumference. So rearranging this, F is equals to 2 pi r t. Ato na substitute ari, so therefore we have now 2 pi r cosine theta t is equals to, how about the weight of the water class? The weight of the water, that is the weight of the water is just equal to the mass of the water times the gravity, and the mass of the water is just equal to the density of the water times the volume of the water. Ang volume ani nga water, ang volume sa water is just the cross-sectional area of this capillary tube multiplied by the height of the water. So that is pi r squared times h times g. Okay? So ato na siya i-plug in dire. So this one is equal to pw pi r squared times height times the gravity. So here, common ang pi makancel, ang usa ka r makuha. So mo r na lang ni ari. So therefore, atong makuha ang surface tension equal to the density of the water or the fluid times the gravity times h divided by 2 cosine of theta. Ang theta is angle sa ato ang surface sa fluid with respect to the wall, with respect to the wall of our capillary tube. So this is the general formula for the surface tension of our capillary tube, and then the unit is again in Newton per meter or force per length. Okay, any question? I think kuangan din napa din siya R. Density times gravity multiplied by the radius times the height. Okay, pangutana class. Class, pangutana regarding sa derivation sa usa sa mga applications sa surface tension kaning capillary tube. May pangutana? Okay, if wala pangutana, then let's proceed to some examples for this one. So, problem number 1. So, ingon siya diri, a capillary tube of diameter 0.5 mm is dipped into a liquid vertically and the liquid rises to a height of 6 cm. If the density of the liquid is 1000 kg per cubic meter, calculate the value of the surface tension of the liquid. So use gravity 9.81 meter per second squared. So we're going to write the given. Given here is we have diameter of the capillary tube. So that is D equals 0.5 mm. Then naay liquid nga miray sa capillary tube, that is the height, which is 6 cm. Then the next one is the density of the liquid. Density of the liquid is equals to 1000 kilogram per cubic meter. And then another thing is, of course, we're given acceleration due to gravity G, 9.81 meter per second squared. Okay, our required here is the surface tension, that is T. Okay, solution. Since nakaderive naman tawag formula for surface tension that is applied on a capillary tube, so therefore that is T is equals to density of the fluid multiplied by gravity multiplied by the radius multiplied by the height divided by 2, then cosine of theta. Okay, so here walay given ani ang walay given ang angle. So in this case mag-assume tag angle, I think marang nakalimutan dyan nga part. So we're going to write theta is equals to 20 degrees. Okay, 20 degrees. So here our density is 1000 kg, that is 1000 10 kg per cubic meter. So that is 1000 then kilogram per cubic meter. Gravity is 9.81 meter per second squared. The radius is twice the diameter, so ang diameter na is 0.5, so that is 0.5 all over 2. Then since this is mm, so aton siya convert into meter, that is 1000 mm 1 meter. the height is 6 cm, so 6 cm divided by 100 cm, yeah, meter na siya, divide by 2, then cosine of 20 degrees. So what is the surface tension? Okay, surface tension 1000 times 9.81 times 0.5 divided by 2 times 6 all over 1000 times 100 divided by 2 cosine of 20. The answer is 0.0783. This is 0.0783. This is in Newton per meter. So muna siya ang surface tension for problem number 1. Question, class. Kaya again, nakalimutan din og kana indicate ang angle, ang pag-rise sa nakalimutan ako butang, that is 20 degrees. 20 degrees yung angle with respect to the vertical side of the capillary tube. Okay, walay question? Walay question, class? Okay, so let's proceed to the next example. So for problem number 2, again, calculate the diameter of a capillary tube in which a liquid rises 2.34 times 10 to the power negative 2 meters. Then surface tension of the liquid is 25 times 10 to the power negative 3 Newton per meter. Relative density of the liquid is 0.79. Angle of contact is 11 degrees 12 minutes. Then G is 9.81. So again, we're going to write the given here. So ang given nga una is ang height. Rise daw siya og 2.34 times 10 to the power of negative 2 meters. Then ang iyang surface tension, that is T, is equals to 25 times 10 to the power of negative 3, that is Newton per meter. We have relative density of the liquid, that is 0.79. Class, unsay buot pasabot aning relative density? Na may idea? So may other term for relative density. Okay, that is the specific gravity. Okay, again, kung makasugat mo relative density, this is the same as the specific gravity. So therefore, we are given specific gravity, that is Sg is equal to 0.79. Angle of contact is equals to 11 degrees then 12 minutes. Ato na siya in decimal point, so pwede pa na nimo type sa mong calculator. Then that is 11.2. That is 11.2 degrees. Then we're going to use G equals to 9.81 meter per second squared. Then required. We are required to solve for the diameter. Okay, solution. So again, since this is a capillary tube, so the formula for our surface tension is T is equals to density sa object or density of the liquid, then gravity, the radius times the height, all over 2 times the cosine of the angle of contact. And then here, since we don't have density of the object, but we have its specific gravity. So remember that the density of the object is equals to the specific gravity of the object multiplied by the standard density, which is the density of the water. So pwede na ito ma-plug in. So therefore, this is equal to Sg, density sa water, gravity RH, all over 2 cosine of theta. Since we're after with the radius, so pwede na po nato maingon nga R is equals to the diameter all over 2. So katay substitute, that is Sg PWG, then this is D
H niya ato na po ibutang ang 2 sa kubos, mayroon siyang 4 cosine of theta. Tungod aning D ha, tungod sa D kay D over 2 na siya, so nakombine lang sa kubos. Then that is T, then cross multiply. This would now become Sg density sa water G dH is equals to 4T cosine of theta. Divide both sides by Sg density sa water GH, Sg density sa water GH. Makancel na siya, mabilin ang diameter. Okay? Diameter is equals to 4 times the surface tension multiplied by the cosine of the angle of contact multiplied by the Sg density sa water G times H. Then, substitute the values. That is 4 multiplied by the surface tension is 25 times 10 to the power negative 3. This is Newton per meter. Then multiplied by the cosine of 11.2 degrees, right? 11.2 degrees divided by Sg is 0.79. This one is 0.79. Density sa water is 1000 kilogram per cubic meter. Then gravity is 9.81 meter per second squared. The height here is 2.34 times 10 to the power negative 2. That is 2.34 times 10 to the power negative 2 meters. Negative 2 meters. Okay, so our diameter now is 4 times 25 times 10 to the power of negative 3 times the cosine of 11.2, then all over 0.79 times 1000 times 9.81 times 2.34 times 10 to the power of negative 2. So, answer class is, okay, wait lang. The answer is 5.41 times 10 to the negative 4, or that is 0.000541. This is in meters, but we can convert this into meters by multiplying 1000. So in terms of millimeter, this is 0.54541 mm. So gamay jud kaayo class. Gamay kay ang diameter sa ato ang capillary tube. Okay, pangutana. May pangutana? So are you still with me, class? Okay, so let's proceed to the next example. So problem number 3, again capillary tube gyapon. So a liquid of density 1000 kg per cubic meter is taken in a beaker. Then a capillary tube of diameter 1 mm is dipped vertically in it. So calculate the rise of liquid in the tube. The surface tension of the liquid is 72 times 10 to the power negative 3 Newton per meter. Okay, so here we are going to write the given. Okay, a liquid of density, that's referred that is the density of the liquid, that is 1000 kilogram per cubic meter. Then ang diameter sa capillary tube is 1 mm. So D is equals to 1 mm. And then tungod ani class nga gidip siya vertically di ay, if this is our capillary tube, gidip siya vertically, meaning wala siya lower meniscus, di ka nga vertically siya. So therefore ang ato diri, ang atong angle, gidip siya vertically, no? So paano din siya, na siya na siya lower meniscus, dako kaayo ang curvature. So man mo approach na siya nga ang tangent sa iya surface na generate is vertical. Unlike sa ato na derive ganiha nga paana siya na siya certain angle nga theta. Here nga tong theta kay 0. Why? Because ang tangent sa ato ang pag dips, ang tangent sa atong surface sa water kay kuan man siya kanang almost 90 degrees. So therefore ang atong theta ani, if makasugat mo deep vertically, theta is equals to 0 degrees. Okay? Again, theta here is 0 degrees kay gidip nim siya vertically. So ang surface kay may tangent na siya. Ang surface sa water kay may tangent na pud siya sa surface sa ato ang capillary tube. So kani tangent sa surface. Okay, so again, the angle of contact is 0 degrees. Okay. So here, padayon ta. So ang uban nga given kay surface tension. So the surface tension daw sa capillary tube is 72 times 10 to the power of negative 3 Newton per meter. So what is the required here? The required is calculate the rise of liquid. That is the H. So ang H may gipangita. So solution. So again, kay bago ta sa formula for surface tension, that is T is equals to density sa object, then gravity times the radius. Kani siya kay diameter man, so that is D over 2. H all over 4 cosine of theta. So na 4 ni siya tungod kay sa diameter din atong gigamit. So since H gipangita, cross multiply, so we have density GDH is equals to 4T cosine of theta. Divide both sides by density GD over density GD. Mabili na lang si H. So si H is equals to 4T cosine theta all over density GD. Then substituting the values, 4 times the surface tension is 72 times 10 to the power of negative 3 Newton per meter. Cosine of 0 degrees all over density is 1000 kilogram per cubic meter. The gravity is 9.81 meter per second squared. The diameter is 1 mm. So since meter man ang uban ari, so convert ang 1 mm into meter. 1 mm over 1000 mm is equal to 1 meter. Okay, cancel. Then cubic meter, ma-meter na usa. Then napo diri ma-cancel, so therefore ang nanay mabilin diri. So ang Newton kay naman na siya ikuan. Ang Newton is in kilogram meter per second squared. So kilogram makansel diri, second squared makansel second squared, therefore meter. So ang dimension sa atong height is in meter. Then simplify, so 4 times 72 times 10 to the power of negative 3 multiplied by cosine of 0 is automatic 1 na siya class. Then multiplied by 1000 times 9.81 times 1 all over 1000. The answer is 0.03, approximately 0.03 meters. So muna siya atong height sa ato ang rise sa tubig inside a capillary tube. Pangutana. Pangutana class. Walay pangutana? Are you still following? Okay. So kung walay pangutana, then let's proceed to the last topic, which is the Bernoulli Principle. So ang Bernoulli kanang principle class, nagkuha na siya, may relate na siya sa mga energy nga nag-interact sa atong fluid that is in motion. So this is under the fluid dynamics nga field. So deals with the dynamics of the fluid. So kani siya, nagrelate ni siya sa energy, nagrelate ni siya sa energy of the fluid, energy of the fluid in motion. Okay, energy of the fluid in motion. So since na-discuss na po na ko yung katong about mechanical energy, so the same rin po ng principle sa pag-derive na to sa Bernoulli. So naman ko tayo gitawag nga popular nga Bernoulli equation. Kaning Bernoulli equation class in your higher subjects inyo gining masugatan again and again and again until gid mo graduate. Okay, so how are we going to derive for the formula for this Bernoulli? So again, ang Bernoulli is used to analyze a fluid that is in motion. Tungod kay makuha nato ang mga properties of fluid from a particular position or a particular state. So unsa tay mga properties nato makuha, sir? So makuha nato ang pressure anang fluid. Makuha nato ilahang pressure, makuha nato ilahang velocity, makuha nato ilahang volume flow rate, ang kapaspason, makuha po nato ilahang elevation, and makuha po nato ilahang temperature in some cases. So mo na siya for Bernoulli. So for Bernoulli, we're using the conservation of energy. So the law of conservation of energy. Okay, unsa toy sa law of conservation of energy, that is energy in is equals to energy out, or the energy at state 1 is equal to the energy at state 2, assuming that we don't have energy losses. So in this figure, as you can see, we assume nga mo ang state 1 or the input, then state 2 mo siyang pagawas niya yung exit na o the output. So ang fluid kay mo flow from point 1 until point 2. So ato ning gamito ning mga variables nga gisuwat sa figure. So here ang kaning F1 is equals to P1A1. So kanatong P1 or atong P nag-indicate na siya sa pressure. F is the driving force or the pressure force. Our V here, kanan nyo nakitaan, kaning V, that is the velocity. And then kaning Y, muna siya ato ang elevation. What else? Ang kanang big letter V, that is the volume flow rate. And then kanapong area, muna siya cross sectional area. Okay, muna ang nasa tong figure. So again, balik ta sa law of conservation of energy, that is energy in equals energy out, or energy at state 1 equals energy at state 2. So in analyzing Bernoulli's equation, especially in dealing with fluids class, ata lang gineglect thermal energy. Meaning wala tay heat nga gipasod sa system, mo pa tay heat nga gi-reject sa system. So i-neglect na nato mga thermal energies, diba? Daghan man ta katong enthalpy, entropy, mga mga work at constant pressure, at constant temperature, so on and so forth. So diri ang energy lang nga present nato is katong mga common energies nga to masugatan, especially an object in motion. So here ang unang energy nato is the kinetic energy. Since nag-movement ang fluid, natin kinetic energy. So we have kinetic energy at point 1 plus what else? Since this is our datum line, so assuming na naputay datum line, so remember sa atong discussion, if we have datum line, so meaning na siya corresponding elevation ang atong mga states. So nagamit na diri ang potential energy. That is potential energy plus what else? Since namatay pressure nga i-exert sa state 1, so therefore natay force nga ma-produce. If natay force nga ma-produce, since nag-movement siya at a certain distance, so therefore natay gitawag nga work. That is mechanical work is equals to the kinetic energy at point 2 plus the potential energy at point 2 plus the mechanical work at point 2. So again, ang kaning work ari is associated with the work due to the pressure exerted by the fluid. What is the formula for kinetic energy? That is 1/2 mass of the fluid times the square of its velocity at volume 1 plus 1/2 times the, ang potential energy kay mgh naman siya. That is mass sa fluid nga hingsod sa ato ang pipe or system, then gravity times the elevation. Elevation at point 1 is y1, diba? Na y1 plus the mechanical work due to friction, that is the force times distance. So that is force, that is PA, but that is PA, pressure 1, then area 1 mo ang force times the displacement dx1, so gili-gili dx1. Okay, and this is equal to 1/2 mv1 squared v2 ni plus mg y1 ay y2 ni plus pressure 2 area 2 then displacement 2. Okay, but area 2 and displacement 2 actually pwede na siya makuhan, pwede na siya makombine because this kuan ay makaingon ta, but area times displacement is equals to the volume, right? Volume. So pwede din natin siya masubstitute diri. So therefore, after doing also, ato pod buhaton ning mag-multiply ta og 1/m sa usa-usa. So that would equal to v1 squared all over 2, then plus gy1 all over gy1 na dira. There's gy1, then plus this one is p1, then v1 is a volume, is equals to v2 squared all over 2 plus gy2 plus pressure 2 then volume 2 or the volume flow rate. Okay, here pwede po ka multiply over m din siya, nag-divide na multiply tag 1/m, so 1/m pa diri. And then what else? So ano pa man? So in this case, di ba, relating mass flow rate and volume flow rate, so ay magkakuha na ng mga mass flow rate o volume flow rate, that actually ang kanang mga mass flow rate per second na siya, and also volume flow rate, that is volume per second, therefore volume per time. But na po tay relationship man nag-exist sa atong mass of volume, that is, di ba, density is equals to mass over volume. So therefore mass is equals to density times the volume. So ato na i-plug in, that would be v1 squared over 2 plus gy1 plus p1 diri na pod v1 all over density, then v1 is equals to v2 squared over 2. So kaniha ang atong density 1 ako og density 1 kay assume nga uniform ang density sa fluid bisan pag mo change siya from state 1 to state 2. Plus G Y2 plus P2 then V2 all over density times V2. Okay. Here makancel ang V1 mga volume flow rates. Then pwede pud ta ka multiply sa tanan by 1 over G. Okay? Kaya if we're going to do that class, ang tanang term sa ato ang Bernoulli equation kay height na ni siya. Ay kita ragod. So for kinetic that is V1 squared all over 2G na plus the potential energy is the height. So therefore, height na ni sila tanan. Kaya muna na siya simplify. Plus, diri may mo siyang pressure 1 all over density times G is equals to V2 squared all over 2G plus Y2 plus pressure 2 all over rho G. Okay class, as you remember, unsa ragod tong density times gravity? That is just equal to sa to? Kanimdong pa mo? Density times gravity is equals to, okay, that is specific weight of the fluid. So therefore, that is V1 squared all over 2G plus Y1 plus pressure 1 all over specific weight is equals to V2 squared all over 2G plus Y2 plus pressure at point 2 all over the density. Okay, this is now the general equation for our Bernoulli. So general equation sa atong Bernoulli. So may siya class. So unsa din importante ni sir? Of course, if usa is unknown diri, so makasolve ta by having other parameters. Let's say given ang pressure, given ang velocity at state 1, then makasolve din ta sa velocity or elevation at state 2. And class sa Bernoulli Principle, so ani kalimti ha. Sa Bernoulli Principle po class, not only the law of conservation of energy applied, na po tayo gitawag nga kanang law of conservation of mass. Law of conservation of mass. And then here we can say nga ang mass flow rate di ay sa point 1 is equal to the mass flow rate of point 2, meaning ang mass nga may enter is equal to mass po ning exit, meaning walay mass na bilin sa system, wala po nagkaon or na-destroy ang mass. Of course, lisod ka na i-destroy ang mass. So if we have this, therefore, di ba ang mass 1 is equal to the density at point 1 times the volume flow rate at point 1. Then we have density at point 2, volume flow rate at point 2. Assuming class, assuming incompressible ang fluid. Incompressible. Say but pasabot ani. And assuming nga walay assuming nga gineglect po nato ang thermal energy. So therefore, if this is incompressible, we can say nga wala nag-change ang ato ang density. So therefore, density 1 is equal to density 2, which is equal to the density of the fluid. So we can say that is density V1 is equal to density V2. So makancel na siya. Therefore, the volume flow rate at state 1 is just equal to the volume flow rate at state 2. This is the continuity equation. So famous kani sa fluid mechanics, continuity equation. So again, more ni muna hunaon sa pag-analyze og mga problems that deals with fluid flow. Again, una nato is the law of conservation of energy. So mao na to kani siya gamit ani Bernoulli equation. So again, kani siya ka in terms of ang height na ni siya class kay di ba y1 height. So nato siya parts. Kani siya ang gitawag ani this the velocity head. Okay, sa fluid class velocity head na siya y because kani siya nga term kay in terms of velocity man. Asa may gitawag pud ani usa? This one is the elevation head. Okay, tungod kay gikan ni siya sa potential energy. What is the head in terms of pressure? That is pressure head. Okay, so therefore di ang pasabot sa general equation for Bernoulli is that The sum of the velocity head, elevation head, and pressure head in the initial state is just equal to the sum of the velocity head, elevation head, and pressure head sa state 2, given that we don't have any losses sa tuwang system. So this is the ideal condition for the flow of our fluid. Okay, so again, ay kalimtin na siya nga formula. Gamit jud kay ni siya. Okay, so nakasunod ra. Walay pangutana so far. Walay pangutana, class? Are you still following? Okay, so let's proceed. Kung may pangutana, let's proceed to some examples. But before that, mo din siya, class, ang application sa atong Bernoulli's Principle. So kani siya, for letter A, mo ni Bunsen burner. So Bunsen burner. Kaning upat ka mga examples, ang principle behind ni is kaning gitawag nga entrainment. Okay, entrainment. Ano sa pasabot sa entrainment? Na kay gamay nga passageway, and then on that passageway dako imong velocity. So if you have higher velocity, na siya mo correspond na siya og lower pressure. Okay, ato na ma-prove sa atong previous nga pag-derive nato ang katong velocity head og pressure head. So kung mataas mo gud ang velocity head ato, tungod kay mag-balance ta og equation, mag-balance ta og values from left side og right side. So therefore, kung dako imong velocity by Bernoulli's equation, na siya corresponding nga decrease in pressure. So maka-create ta og lower pressure. Again, kung sa indication ani, meaning natay suction may tabo ani. And then mao na ang makita sa atong mga entrainment nga mga devices. Let's say sa Bunsen burner, na kay air ari nga paspas kayo, so mo accelerate siya ngadto. In this part right here, ang intersection sa natural gas o sa air, so ma-create dra og low pressure. Okay, so kung ma-create og low pressure, meaning si natural gas gikan sa tank kay mo ngadto gid siya, mo rise gid siya, bisag wa kay motor gigamit or pump nga mo pump sa natural gas parang ngadto. So due to the air, so na airflow, kay mo rise na siya ang natural gas because of this low pressure nga na-create. Kay kung if you have low pressure, na kay suction nga naitabo diri, mana mo sabay pod og isa ang ato ang natural gas together with the air. And also the same thing sa atong mga perfume, diba? Sa atong mga perfume or sa atong mga sprays, diba? I-squeeze man pag squeeze nimo, kusog kayo ang velocity sa air diri. So if na kay kusog ang velocity sa air, so therefore ma-create na sad ka og low pressure. So kung na kay low pressure nga part, na suction, so suyupon ang perfume padong babaw man kung imo na squeeze, so na perfume nga mo gawas. Another type for an entrainment. What else? This one, na tubig. So diri pod paagi pod sa air at higher velocity, so nana po diri nga part ang low pressure. Okay, I think ang naka-create ani is ang tubig. So ang jet of water, this is water jet. So ang jet of water kusog kay velocity, so therefore okay, dira gyapon sila entrance sa air, tungod kay paspas ang flow sa tubig, ang hangin diri kay mada, so naay suction ara. Naay suction ari mo na ang hangin mapugos og sud tungod kay paspas ang velocity sa tubig, na create siya og low pressure ari nga side. So mara siya for water jet. The last one is in the chimney. So kani siya sa chimney ni siya, wherein natay hot air diri, hing rise ang hot air at higher speed. So pag rise niya at higher speed, kani nga part diri na create na pud siya og another low pressure na pud. So kung low pressure, natay suction man ang gisuck ang cold air padung sa kaninga funnel o kaninga chimney para mo cool ang ato ang kuan water ang exhaust niya. So mo na siya ang application, good application for a Bernoulli Principle kaning entrainment. Again, natay Bunsen burner, mostly for entrainment magina siya. At higher velocity, maka-create og lower pressure, therefore naay suction nga may tabo. Okay. Kung wala pang uta, then let's proceed to sample problems. So here, this problem is taken from the book ni Frank White sa kang kwaday sa kang single and simbala fluid mechanics. This is an example of kanang kuan, example of a Bernoulli principle nga problem or Bernoulli equation nga problem. So here it is stated that water is flowing through a Venturi meter. Ang Venturi meter class, this is just mara siyang pipe nga naa siya kanang na siya dako nga diameter din mo gamay na pud. Mara gyud siya mo in and mo out. Kaning Venturi meter is used to measure flow rate, pressure, and even velocity of a flowing fluid. So yun siya, whose diameter is 7 cm at the entrance and 4 cm at the throat. The pressure is measured to be 430 kPa at the entrance and 120 kPa at the throat. Neglecting frictional effects, determine the flow rate of the water. So ang ipangitan yung flow rate sa tubig. So we have here figure and data. Figure and data. So ang forma sa Venturi meter, so na siya larger pipe niya, na siya throat. Okay, gamay mo siya, singa na siya. Okay, so natay diameter array. This one is D1. And then napatay quadri nga dito. Okay, so D1 is equal to 7 cm. Dito is equals to 4 cm sa throat. And then napatay pressure array P1. And then also P2 pressure here. So P1 is equals to 430 kPa. At point 2 that is 120 kPa, meaning gamay siya. Nganong hinggamay tungod kay kusog na kay imbes diri kay gi-constrict naman siya. Okay? Then what else? So wala na. Then ang required we're going to solve for the volume flow rate. So again, kung sa volume flow rate at position 1, the same na siya sa volume flow rate at position 2. So Q1 is equals to Q2, which is equal to Q na lang. Mong Q na lang akong gi-abbreviate ari. Tungod kay sa ato ang continuity equation ganina. So solution. By using the Bernoulli equation, so we have the summation of force, the summation of energies or mga velocity head, the summation of heads. So unta sa velocity head, that is V1 squared all over 2G plus the elevation, that is Y1, plus the pressure head, so that is P1 all over specific weight, is equals to the velocity head at point 2 all over 2G plus Y2 plus the pressure at point 2 times the specific weight. Okay, ang gigamit ani kay water. So specific weight sa water, ito lang sa what, that is 9.81 kilonewton per cubic meter. Okay. Then here walay Q dira. Pero natay velocity and nabi atay relationship ganiya sa velocity and volume flow rate. But before that, atong kitaon nga since ang Venturi kay wala man nag-increase ang iyang mga elevation sa state 1 of sa state 2, the same naman lang location, so therefore Y1 and Y2 can be cancelled out. Okay, natay given nga pressure but we don't have velocity, but we have diameter. And then kung mabalik ta sa continuity equation, akong gi-discuss ganiha. In the continuity equation class, di ba, we have the volume flow rate at point 1 is equal to the volume flow rate at point 2, di ba? Continuity equation. And then, di ba, the volume flow rate is just equal to the area times the velocity. That is area 1 times the velocity at point 1 is equal to the area 2 times the velocity at point 2. Okay? If we can get the para di ta mailad ang Q kay use as volume flow rate. So, pwede na to i-Q na lang na dira. This is Q1 is equals to Q2. Okay? So, kung makuha tag-usa sa mga velocities, then we can directly solve for the volume flow rate. So, ato lang kuhaan si V1 na lang in terms of V2. So, V1 is just equal to area 2 all over area 1 times the velocity 2. So, ato kuhaan si V1, ang area 2 is equal to pi d2 all over d2 squared all over 4. Then, area 2 is pi d1 squared times 4. So, makancel si 4, cancel si pi, that is d2 squared all over d1 squared times v2. Okay? Then, what is d2? So, d2 is d2 is 4 cm, d1 is 7. So, d2 is 4 cm, that is 4 squared all over 7 squared. So, don't worry with their don't worry sa ilahang units kay makan sila magyapon. So, 4 squared divided by 7 squared. The answer is 16/49. So, this one is 16/49 V2. So, muna ito i-substitute sa V1 para in terms of V2 na lang tanan. So, kato na buhaton. So, ito ikuan diri. So, therefore, we have V1. That is 16/49 V2 squared all over 2G plus ang pressure array plus pressure 1 all over specific weight equal to V2 squared all over 2G plus P2 all over specific weight. So then, plug in the values para dito maglibog. So diri ato na ipagawa si V2 squared. Then, kani siya may siyang 16/49 squared all over 2 times 9.81 meter per second squared. Okay, plus P1 is 430, this is kilonewton per meter squared, divided by specific weight is 9.81 kilonewton per cubic meter, equal to V2 squared all over 2 times 9.81 meter per second squared, plus diri is 120 kilopascal is kilonewton per meter squared all over 9.81 kilonewton per cubic meter. So here, ato i-transpose si V2, i-transpose na on the other side para makombine sila. That is V2 squared is kanit siya, ato na i-simplify ning una. That is kanit siya is 16 all over 49 squared divided by 2 times 9.81. So the answer is very small jugay, that is 0.005443. This is second squared meter. Then minus 1 all over 2, that is 1 all over 2 times 9.81. The answer is 0.0509 minus 0.05096 second squared meter, then equal siya sa difference of pressure. So kaning 120 kani siya ang answer ani, makancel yung kilonewton, ang iyang units, resulting unit is in meter gid. So meter, that is 120 divided by 9.81 The answer is 12.23. This one is 12.23 meters minus kanin siya since ato nag-transpose, so minus siya, that is 430 divided by 9.81, so that is 43.3, so minus 43.83 meters, approximate value ni siya. So therefore, ang V2 squared is equals to kani, this one divided by this. Okay? This one divided by this. So, nahimo na siya 12.23 minus 43 ba na? So, 43. 43.83 divided by 0.0054343 minus 0.05096. The answer here is 694. So 694.11, that is meter squared second squared. 11,343,348 meter squared second squared. Muna ato i-take ang square root, that is V2 is equals to the square root of that, square root of the answer, that is 26.35 meter per second. Since namatay V2, makuha na nato ang volume flow rate by using area 2. So volume flow rate Q2 or Q lang, anyways equal mo yung volume flow rate. Q is equals to the area at point 2 times the velocity at point 2. Area at point 2 is pi over 4, then the diameter at point 2, okay, so na erase, that is the diameter at point 2 squared, then velocity, that is pi over 4. The diameter at point 2 is, diba, 4 cm man, kaya siya 4 cm. In terms of meters, so that is 0.04 meters squared times the velocity is 26.35 meter per second. So the expected dimension is cubic meter per second. So ato na siya ikuan, ato na siya simplified, that is pi over 4 times 0.04 squared times 26.35. The answer is 0.033. Okay, 0.033. 0.033. O ba? Ay, 0.538. I think diri dapit. Ato i-review diri nga part kaning diri kay I think kaning 43.83. Kay ganihan na lahi ni nako pag kuan. And 20 over 9.81. So kani day siya is 12.23. Ang kaning 430 kilopascal. Okay, 430 kilopascal. 430 divided by 9.81. That is 43.83. Then ang kani pong sa volume flow rate, area 1 velocity 1, that is kuan V1 is equal to V2. So area 2 is dito, ang dito kay 4, that is 4 squared all over 7 squared, 16 over 49, 16 over 9 V2, and then kato siya i-kuan solve again, diba signadri ang sayop, squared all over 2 times 9.81. So kuan siya 0.00543 4 3 4 3 6 5 4 3 4 3 i4 na lang ni kan siya nadri nga part class. This one is 4. Then ang kanipong sa usa, so V2 naman siya, so that is 1 all over 1 all over 2 times 9.81. Okay, that is 0.05096. Sa totoo 12.23 minus 43.83. So in meter man okay, kilonewton. So ang specific weight sa tubig kay 9.81 man kilonewton. Okay, so that is 0.00123 minus 0.05096. So 694.11. The square root of the answer, so 26.35 mana siya. So ang volume flow rate pi over 4 times the diameter is in centimeter, no, at the entrance or at the I. This is V2, so V2 kay 4 lagi, so 4 pi over 4, then 4 divided by 100 squared times 26.35. So answer is 0.033. Okay, I think tungod kay na ground off man ta class, mo nang na-diferensya sa answer. Question: if ato po siya i-check Q in terms of area 1, then velocity 1. Okay, since we already have velocity 2, so if natin velocity 2, therefore velocity 1 is equals to 16, kaning 16 times or over 49 times the V2 is 26.35. So ang kanan is 8.60. So 8.60 meter per second. So ito i-check pod pi over 4 times ang diameter niya kay ang initial diameter kay 7 man, diba, 7 cm. Okay, so 7 cm, this one 7 over 100 squared times 8.60. So the answer ani niya kay pi over 4 times 7 over 100 squared times 8.60. The answer is 0.033. So para ra gyapon 0.033. Ang ani kay nag-round off magud ko, wala na ako gi-retain tanan, so mo nang dako ang diferensya sa answer. Question class. Are you still following? Follow pa? Okay, so I think that is the end of my discussion, and then don't worry, ang kana siya pod nga part